In this problem, we're going to look at how we can use economic policy, in this particular case, taxes or a cap and trade, or pollution mandates. We're gonna see how we can use economic policy to minimize or mitigate negative externalities. And in this first example, we're going to tackle the negative externality of smoking. So the problem says you're a data scientist who works for New York City's tax department, and you've been asked to devise policy that would reduce negative externalities. Currently, you have two projects. The first one seeks to find the tax rate that reduces daily cigarette consumption in New York City by 20%. During research, you find that the typical smoker smokes 17.9 cigarettes per day. So I'm going to go over here to Excel, and I'm just going to type 17.9 cigs per day. When I put units below in the second row, that's division, right? So cigs per day. And then 14.3% of New Yorkers smoke. Okay. All right, and there are 8.6 million people in New York. We'll do 6 million New Yorkers. We'll call it New York Cityers, right? And we're going to do 20 cigs per pack. Now, cigs are up here, so we're going to put the 20 cigs per day down here. So we got 20 cigs per day. Okay, so what's going to end up happening is I put the 20 cigs down here because I want to cancel out cigs, right? I want to cancel those out. Okay. I'm going to cancel them out, strike through. I'm going to cancel those out, right? And then I'm going to get rid of that. And so now we have a simple algebra problem. The things that are in the numerator, these numbers are multiplied by each other, and then we're going to divide by the 20. So this will, and then the day. Oh, this is pack. Sorry, pack. So we're going to change this to packs. Okay, so we're going to end up with packs per day. All right. So we got 17.9 million times 14.3% of New Yorkers, right, or smokers. Then we need to divide by the 20. And this will give us the number of packs of cigs per day. Okay. If I add a comma, right? So we got 1.1 million packs of cigs per day. So I'm going to type this in without the commas. 1100671. Okay. Now, one thing to note is there are already cigarettes in New York City, right? So this is what the after tax level of cigarette smoking is per day in terms of packs smoked per day, right? Okay, so we've estimated the demand curve and we've estimated the supply curve. we have them down here, right? The demand curve is steeper than the supply curve, which means demand is relatively more inelastic than supply. Okay, I went through and I graphed it for you in PowerPoint. I got the vertical axis labeled P. X-axis is labeled Q. Demand curve is labeled D. Supply curve labeled S, right? Pre-tax, the equilibrium is $2.18 per pack and 1.364 million packs would be sold per day. Okay, I got those numbers from the Desmos worksheet. I have my demand curve, I have my supply curve. The intersection of demand and supply is 2.18, right? 2 decimals, and 1.364. So let's go back to my problem here. So the equilibrium quantity of cigarettes is 1.364. The equilibrium price is 2.18. Okay, so now we want to find the tax rate that reduces daily cigarette consumption in New York City by 20%. So what I'm going to do here is roll down. My quantity currently is 1.364, right? That's my initial quantity. I want to reduce it by 20%, right? So 20% of the 1.364 is that. So 20%, if I subtract the two, I get what we want quantity to end up being after the tax, right? So this is what we want the quantity to be after the tax, because we want to choose a tax rate that lowers consumption by 20%, and this is a 20% reduction, right? Okay, so in order to find the per tax rate, the per pack tax rate, what we need to do is we need to use the demand curve to find out what consumers are willing to pay for, what they're willing to pay at this reduced level of consumption, right? So we need to plug this value into our supply curve, or our demand curve. And we can do that over here with this right here is our quantity, right? Our reduction in quantity. Whoops. At the equilibrium, our quantity is 1.364. So let me change this to a 4. Right? And then if we multiply that by 80%, we get the 1.091. Right? We get the 1.091. Okay. Then that gives us the price. So this is this vertical line here, right? It's that vertical line right here that you can barely see. So at this quantity of 1.091, the price that consumers are willing to pay, the most are willing to pay at that level of quantity, is 3.54. Let me change this to 1.091. Okay, now let's redo that again. Okay, so now we got 3.55, right? So rounding off makes a difference. I'm going to use rounded off numbers to get these values. Okay, what at this level of quantity, what's the lowest price firms are willing to accept? Well, that'd be on the supply curve. So 1.091 is the quantity, and at that reduced quantity, firms are willing to accept a price no lower than 2.05. Okay, so the difference in the two is the tax rate we need to propose, right? So the difference in the two is 1.5, right? If I had 1.5 to 2.05, I get So 0 and 5 is 5, 5 and 0 is 5, and then 1 and 2 is 3. So we get 1.5, right? Okay, so if we impose this tax on firms selling cigarettes, that will shift the supply curve from black up to blue, right? And this is that quantity, 1.091, right? 1.091. And this is that price, 3.55. And this is the lowest price the firms are willing to accept, okay? Which is 2.046, right? In the PowerPoint, that right there is the consumer surplus before the tax, and this is the firm surplus after the tax, right? And that's total surplus before the tax. Okay, now the tax is imposed on the firms. Quantity drops 20% to 1.091. The price net of the tax that consumers pay per pack is 3.55. And the price that firms get net of the tax is 2.05, right? And then that difference is the amount of the tax, right? Okay, now we want to find the tax revenue that's generated by the tax. What is the revenue generated by the tax? Okay, the revenue generated by the tax is this green rectangle, right? And the height of the rectangle is 1.50, right? That's the height of the rectangle, the tax. The length of the rectangle is 1.091, right? So the amount of the tax is 1.091 times the 1.50, right? I need to put an equal sign in front of it. And we get 1.637, right? So this is, remember, it's in millions, right? So 1.637. Okay, in 2 decimals is 1.64, right? That's per day. That's per day. So what is it per year? Well, we're going to assume that in the typical year, there's 365.25 days per year, right? So we're going to come in here, we're going to multiply this by, we're going to multiply it by 365.25. And we get $597.73 million per year. So it's quite a bit of sum. It's quite the sum. Make sure it works. Okay, what I had to do is I come back over here to Excel, and I used a rounded off number, the 1.64. So if I used a rounded 1.64 that I used here, then I multiply that by 365.25, I get the answer that Canvas is willing to accept. Okay. Now, if you remember from our tax burden problem earlier in the term, who we tax makes no difference in who bears the burden of the tax. So let's go back to our PowerPoint here, right? So this green box is our tax revenue box, right? Green box is our tax revenue box. That right there is our consumer surplus. That's our firm surplus. The blue and the red together are the total surplus, right? The government has extracted the green box as revenue. And then this black triangle here is what's called the deadweight loss, right? The marginal smokers, or the marginally addicted smokers, are no longer smoking, right? Because the most they're willing to pay is less than this price that includes the tax, $3.55. So they're out of the market. The marginal firms, the ones that don't have the economies of scale and have higher cost structures, they're out of this market too, right? So this is lost. This is the lost value of the voluntary transactions that were going on prior to the tax, right? Okay. So now what we need to do is we need to figure out who pays the burden. Okay, so before the tax, consumers were paying $2.18. After the tax, this new marginal consumer is paying $3.55, right? So this right here is the amount per. This difference is the amount per pack of the consumer's tax burden, and this difference down here is the amount per pack of the firm's burden on this tax. And then this really slender gray rectangle between blue and red dashed lines is the firm's total tax burden, right? And it's much smaller than the consumer's tax burden, which is between this blue dashed line and this red line. So although firms are taxed because the consumers are so heavily addicted to cigarettes, they're very insensitive to a price change because their demand is inelastic. They are their burden on the tax is much greater than that on the firms. So let's go back to our problem here. So the tax burden borne by cigarette producers is less than the burden borne by consumers. Okay, so we got the first part right. The tax was able to reduce consumption of cigarettes. Now, here's the interesting thing, right? The people on the demand curve from here to here are the heavily addicted consumers. They don't change their smoking behavior at all. They're still smoking the same number of packs per day. The people that have been eliminated from smoking by this tax are the people here, and they're the marginally addicted smokers. They could be kids in high school that don't have a job. Maybe the tax priced them out of the market, right? So the marginally addicted or new smokers are eliminated from these voluntary exchanges, right? Now, the thing about the tax is it makes smoking more expensive for the heavily addicted. So they have to use money that we're going to maybe spend toward healthy foods and healthy drinks. They're using that money from their budget to buy these cigarettes. So their budget is smaller, and they might have to resort to buying foods that are not very healthful, right? You might have to switch from salads to top ramen, for example, right? So this policy actually could have a negative health effect on the heavily addicted, right? It has a positive health effect on these marginally addicted smokers. They're no longer smoking, they're priced out of the market, right? Now, with regard to the firms, maybe this value here demarcates or separates the low-cost, big, established firm that makes and sells cigarettes from smaller, higher-cost producers of cigarettes. So this policy, if that is true, what happens is the competition from the higher-cost producers is eliminated by the tax. So you end up having one firm left in this market, and their tax burden is tiny, right? Because their consumers are addicted to cigarettes, so their tax burden is small. So for that one big firm that has the economies of scale and low cost of production, this tax basically renders them unscathed, right? It eliminates their competitors, right? It eliminates their competitors. So those are the implications of this, right? The policy might have a negative a health effect on the heavily addicted because now they're not spending money on healthful foods. They're spending money on lower price, unhealthful foods to pay for their smoking addiction, right? It does improve unless these smokers turn to the black market. It does improve where in the black market, you don't have to pay the taxes, right? It's illegal commerce. So if these people don't go to the black market, it can end up improving their health outcomes, all right? Okay, so moving on to the next part of the question. Okay, in our next project that we're doing for New York City, we want to figure out how to reduce pollution that 3 firms are doing, right? Now, your table is going to be different than mine. My old established firm with old technology is firm A. It finds it very difficult and costly to reduce pollution. Yours might be firm B or firm C, right? So you can kind of think of the firm with the lowest cost per ton. You can think of that as the newest firm with the newest technology. So my newest firm is firm B. My next newest firm is firm C, and the old established firm is firm A, right? So in order to do this problem, I'm going to copy the table into Excel. Now, because this is an HTML table, what you want to do to preserve the table format is copy the table and this period up here, right? You want to copy something outside the table and everything within the table. So I'm going to come over here to Excel and paste it in here, and I'm going to double click on these to automatically size it. Okay, so we're going to use the above table to calculate the cost of eliminating 2 tons of pollution for each firm. So firm A finds that their first ton of pollution reduction to be pretty expensive relative to B and C. And because of diminishing marginal productivity, the very first ton of pollution reduction is going to be much less expensive than the last ton of pollution that is reduced, right? It's like your GPA. If you spend an extra hour a day studying, your GPA might go up like a full point from 3 to 4. But to go from, it might go from 2.5 to 3, right? It might go up a half a point. But to go up from 3 to 3.5, you might need to have 2 extra hours of study per day. And then to go from 3.5 to 4.0, you might need 5 additional hours per day to get your GPA to rise to 4, right? That right there is the law of diminishing marginal productivity, right? So that very first unit of pollution is going to be cheaper than, say, the 100th ton of pollution reduction, right? So that's why these numbers are increasing for each firm, right? So the cost for firm A to reduce pollution by 2 tons is going to just be the sum of these first 2 boxes, right? And the same thing for firm B and C, right? So firm B is going to be really costly for them to eliminate pollution, those first 2 tons of pollution. For the newest firm, it's not going to cost much, right? It's going to be a fraction of that. And then similar for firm C, right? Again, firm A is the old established firm, right? Okay, we got those correct. Now, the first proposal you're reviewing is just a government mandate. And the government mandate is that each firm must reduce its pollution by 1/2, right? So now you need to calculate the cost to society of this policy, right? Well, the cost of this policy is just this total here, right? It's just the sum of the 3. Okay, so pretty substantial cost here. Okay, now this means firm A reduces pollution by 2 tons, firm B reduces pollution by 2 tons, and then firm C reduces pollution by 2 tons, right? We'll go ahead and hit enter. And we got that right. Right? There's proposal 1 is pretty costly, right? Pretty costly. Proposal 2, in that proposal, the government issues 2 non-transferable 1-ton pollution permits, right? So this gives the firms a license to pollute 2 tons each, right? But it's non-transferable. That's the key. It's non-transferable. So what ends up happening here is the last 2 tons are really expensive. Given the firm, the last 2 tons are really expensive. So this is basically a license to pollute 2 tons of pollution, right? So this is the same outcome as a mandate, right? In this particular situation, it's pretty expensive, right? This license to pollute 2 tons is just as costly as the mandate to reduce by 50%, right? Just as expensive. It also results in 2 tons being polluted by firm A, 2 tons being polluted by B, and 2 tons polluted by C, right? Now, here, in Proposal 3, you've kind of thought things through a little bit. You're trying to figure out a lower cost to society, right? I mean, you're a politician, and if the cost of society is extreme, that might result in high levels of unemployment. And if people are unemployed, you might be out of work because the person that hired you, the mayor or the governor of the state, that person might not get reelected, right? So you want to explore other options that aren't so costly, right? Some lower cost options that result in the same amount of pollution reduction, right? Okay, so you know that firm A is the firm that's been in business the longest. They have the old machinery, they have the old factory, and so they're going to be willing to pay. They're going to be willing, you got these permits, right? You might think A might be willing to buy a permit from firm B and maybe buy one from firm C, right? If they were transferable, A knows that B is a new firm with new equipment, and its equipment and people don't pollute as much as it does, right? So firm A knows that pollution reduction at B and at C is much cheaper, right? So B and C might be willing to sell A permit each, right? Okay. So we have a pretty good idea. If that first ton of pollution reduction for firm A is 19,500, then firm A is going to be willing to pay up to that value to maybe buy one of those permits from, say, firm B, right? Now, because its second ton of pollution costs more to eliminate, it costs $23,000. We also know that firm A might be willing to buy, is going to be willing to pay up to $23,000 for one of those transferable permits, right? Okay, so recognizing that is a really key important thing here, right? So, if the permits are made transferable, we have a pretty good idea that B and C will be willing to sell one or more of their permits to A, right? So, under this cap and trade policy, quote unquote cap and trade policy, that's what this is, firm A will buy one from firm B. Firm B is a new firm. headed by young people, and they're not going to sell all of their permits, right? I don't think they're going to sell all their permits. But they might sell one of their permits, right? So firm B will sell one of its permits, and then firm C will sell one of its permits. And doing this allows them to signal to everybody that, man, we reduced our pollution by 3 tons each, right? But then they can sell a permit to A each, right? So it allows them to demonstrate that they're really aggressive at reducing pollution, and at the same time, they're selling a permit to firm A, right? Okay, so firm A wants to buy 2 1-ton pollution permits. It's probably going to get one from B, and it's going to get the other from C, right? Now, because it knows the first ton of pollution is cheaper to eliminate than the second, if it offers to buy a 1-ton pollution permit from B and one from C, in my particular case, right? So what ends up happening is when B sells a permit to A and when C sells a permit to A, that means B has one permit left, and C has 1 permit left, right? So A has a total of 4 permits, right? So A doesn't have to reduce its pollution at all. B has 1 permit remaining. C has 1 permit remaining. So what ends up happening is A doesn't reduce pollution at all. B reduces it by 3 tons, and C reduces it by 3 tons. So the amount of pollution that the 3 firms do in total is 6 tons, right? 6 tons. So it's the same outcome as up here, right? Only this time it's cheaper to the society, right? To calculate the cost of society, we have to sum up these 6 values here. Okay, so what these 6 values represent is firm B reduced pollution by spending $990 to eliminate that first ton of pollution. Then it spent $2,300 to reduce that second ton of pollution, and then it spent $4,100 to reduce that third ton of pollution. Firm C, the same thing, right? So we just add up those 6 values, and that's the cost to society. So what ends up happening here is firm A would not reduce its pollution. Firm B reduces by 3 tons, and firm C reduces by 3 tons, right? Okay. Now, proposal 4, the government poses, we're gonna consider government just imposing an emission tax of $6,435 per ton, right? Okay, so it results in the same outcome, right? Because the tax is in between these 2 values, right? Firm A finds it cheaper, firm B finds it cheaper than paying this tax to reduce that ton of pollution, reduce that ton of pollution, and reduce that ton of pollution, because these are cheaper individually than the tax. Same thing for firm C, right? Now this 4th ton costs more than paying the tax. So instead of reducing the 4th ton of pollution, on that 4th ton of pollution, firm B will just pay a tax of $6,435. And that's the same with firm C. Now firm A just pays the tax here, 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 and here. That's cheaper than reducing pollution by 4 tons. So firm A's total tax is 4 times this tax rate, right? And then firm A's tax it pays is 1 times the tax rate, right? And same with firm C. So the government here collects, let's it looks like it collects about $26,000 roughly, right? Or no, sorry, $38,000. Maybe $39,000. Yeah, $39,000 total. Okay, so that's how much revenue the government collects there. The cost of society is the same as it is in the cap and trade policy, right? Because firm B spends that much money to reduce pollution by 3 tons. Firm C spends that much money to reduce pollution by 3 tons. So the cost of society is the same as it is in the cap and trade policy. Okay, and firm A pays tax on 4 tons, so it does not reduce its pollution. Firm B pays a tax on that 4th ton only, because it reduces pollution by 3 tons. Firm C does the same as B. It pays tax on that 4th ton and reduces its pollution by 3 tons. Okay? All right, so we got all those questions right. Now, you'll read this article here, and then the stuff down here are excerpts from this article, and you'll just find the words or phrases that go in each one of these boxes, right? And then you'll use this reading here to recommend which policy is the best, right? Which policy is the best? Policy 4, policy 3, policy 2, or policy 1, right? You'll make a recommendation there.